Hello everyone, my name is Gunjan Sarsat and I'll walk you through my modeling approach and how I built and evaluated the models and to interpret the final results for the combined cycle power plant energy prediction project. So first let's discuss the modeling approach. So because our goal is to predict a continuous numeric variable, the net hourly electrical energy output in megawatts. This is a supervised machine learning regression task. So for my features, I used all the four available ambient variables like temperature, ambient pressure, relative humidity, and exhaust vacuum. Because these environmental factors can interact in complex ways, I decided to test two algorithms: a standard multiple linear regression for a baseline and a random forest regressor, which is excellent at capturing non-linear relationships. So moving on to model building, to ensure my models could generalize to new data, I first split the 9568 data points, setting aside 20% purely as an unseen test set. So on the remaining 80% training data, I used five-fold validation to optimize and compare my two algorithms. As my evaluation metric, I chose root mean squared error. I selected RMSE because it penalizes large errors and expresses the error in the exact same unit as our target variable, that is megawatts, making it highly interpretable. So during cross validation, the linear regression model yielded an RMSE, while the random forest performed significantly better with an RMSE, right? So because the random forest performed better during validation, I selected it as my final model. I then trained this model on the entire training set and evaluated it against the 20% test set that we held out at the very beginning. On the test set, the final model achieved on the test set, the final model achieved a good RMSE. So to interpret these results, our plant generates between 420 and 496 megawatts of power. So this is a highly accurate model. Practically, this means plant operations can confidently use these ambient sensor recordings to predict energy output, allowing them to optimize grid distribution and anticipate capacity within a very narrow margin of error. So thank you for your time, and I look forward to your feedback. Thank you.